Hi guys, so today we will be doing the problem called reverse linked list from the Leetcode 206. So the question says, given the head of syncly linked list, reverse the list and return the reverse list, right? So if you look at the example 1, we're given a linked list with 1, 2, 3, 4, 5, and our answer is reverse of 4, 5, 4, 3, 2, 1. And then if you look at the example 1, it's same thing. And then our example 3 has an interesting case where the head is given as an empty array. So in that case, we would just return an empty array. So let's figure out our input, output, and constraint and edge case. So our input in this case is single linked list, and we are given the head of the list. And our output is reversed linked list. So our constraint, we would put it as optimize, since there is no specific constraint. So we always have to make sure that our problem is optimized, right? And our edge case in this case would be our third example. So if the head is empty array, then return empty array, right? Okay, so let's take care of the edge case first. So we can say if head equals to empty array, then I would just return empty array, return empty array. So let's try to type out the problem and see if that helps us solve the problem. So let's take this example 5. Okay, so you guys know that end of the linked list would be null. The end dot next will basically be the null. So in order for us to reverse this, we would have to create the node called null, right? So we would have, since we need the null coming from this end, so let's say we have null here, and then we can assign that. Let's say that one is a previous, this one is a current, and this one will be next, right? So our goal is to make this happen, right? So this arrow will be pointing this way. So in order for us to do that, we would have to dissolve this connection. So that's why it is really important for us to have this label as a next already, because once we lose this connection, and we would completely lose access to the rest of the linked list. So it's wise for us to label this as a next already. So even when we dissolve the connection, we still have access to use it for later. So if we were to remove this and point the current to the previous, then what would happen is that our previous will be current dot next. So that makes sense, right? Since this one would be current, and if we have this pointing here, that means our previous would be the current. And we would have to do the same thing over and over again until we hit the end. So now what we can do is convert the current, assign the previous as a current, and then current as the next. And then our next would go here. So we would have to keep doing that until we hit the end. So what we can do is, let's kind of write down what we just talked about. So our current dot next would be the previous value, since if you think about it, at this point when we do this, our next is technically the previous, right? So this was next first, but then it will be previous, since it's going to be pointing toward this part. And we basically have to keep iterating through. Once we get to this null, then we are done, and then we can just return our reversed linked list. Okay, so let's say what we can do is say let current equals to head, because we are starting with 1 here, right? And we can say let previous equals to new node, and then assign that to null. So we are doing this case where our previous is null. And now what we have to do is go through the while loop. So we'll say while current is not equal to null. So right here we want to stop, because if we get to this part, then we have already reached our outside our while statement, right? So we only want to reach until here. So what we can do is, like I said earlier, we want to make sure that we save our next node, right? So what we can do is our next node will be in current.next. And I want to, like I said earlier, our current next would actually be the previous, since we're flipping the arrow, and this one is, so current.next, this next will be pointing toward our current, which means this one is previous now. So what we can do is say current.next equals to previous, and then our previous would be current. Since we have to keep looping through the linked list, we want to make sure that we assign the previous to current, and then our current would be the next. So at the end we would just return the previous. So that should solve our problem, but let's try to run it and see if we get the answer. Okay, so it's probably because it's labeled as list node, not node. So it will be list node. Okay, let's try to run that again. Okay, we're getting output. So we have 0. Okay, let's try to take the edge case out. I'm not really sure why I'm getting 0. So that's not why I was getting 0. Okay, let me try to debug this. Actually, I think we can just make this a null. Maybe that's why it's giving me 0. Okay, yeah. Let's try to run it. It's accepted. Yeah, so yeah, you don't have to assign node as a null since it's already a null value. You can just say null. And also, for if it is a bit confusing, this part, just like draw the arrow and then try to like see what our previous would be and what our current would be once we change the arrow around, and that will hopefully help you understand it better. It's just a lot better if you just like walk through the example and see what value will become what once you flip the arrow. Anyhow, hopefully that helps you understand a little bit more, and I'll see you guys in the next video.